Many people are familiar with the hole in the ozone layer over Antarctica, but what is less well known is that occasionally, the protective ozone in the stratosphere over the Arctic is destroyed as well, thinning the ozone layer there. This last happened in the spring months of 2020, and before that, in the spring of 2011. Each time the ozone layer has been thinned out, climate researchers subsequently observed weather anomalies across the entire northern hemisphere. In Central and Northern Europe, Russia and especially in Siberia, those spring seasons were exceptionally warm and dry. In other areas, such as polar regions, however, wet conditions prevailed. Whether there is a causal relationship between stratospheric ozone destruction and the observed weather anomalies is a matter of debate in climate research. The polar vortex in the stratosphere, which forms in winter and decays in spring, also plays a role. Scientists who have studied the phenomenon so far have arrived at contradictory results and different conclusions. New findings are now shedding light on the situation, thanks to doctoral student Marina Friedl and Swiss National Science Foundation Ambizioni fellow Gabriel Chiodo. Both are members of the group headed by Thomas Peter, professor of atmospheric chemistry at ETH Zurich, and are collaborating with Princeton University and other institutions. Most climate models consider only physical factors, not variations in stratospheric ozone levels, in part because this would require much more computing power. But the new calculations make it clear. The cause of the weather anomalies observed in the Northern Hemisphere in 2011 and 2020 is mostly ozone depletion over the Arctic. The simulations the researchers ran with the two models largely coincided with observational data from those 2 years, as well as 8 other such events that were used for comparison purposes. However, when the scientists turned off ozone destruction in the models, they could not reproduce those results. What surprised us most from a scientific point of view is that, even though the models we were using for the simulation are utterly different, they produced similar results, says co-author Gabriel Chiodo, SNSF Ambizioni Fellow at the Institute for Atmospheric and Climate Science. A strong polar vortex then produces the effects observed at the Earth's surface, Chiodo says. Ozone thus plays a major role in temperature and circulation changes around the North Pole. This allows for better prediction of heat and temperature changes, which is important for agriculture, Chiodo says. Materials provided by ETH Zurich. Original written by Peter Ruig. Note: content may be edited for style and length. Marina Friedl, Gabriel Chiodo, Andrea Stenck, Daniela IV Domison, Stefan Fuglestaler, Julian G. Anet, Thomas Peter. Retrieved July 7, 2022 from ift.tt/5w/ETH Ed Zurich. Ozone depletion over North Pole produces weather anomalies. Science Daily. ift.tt/5w/ETH, accessed July 7, 2022. Thanks for watching. Please subscribe my channel for more videos.